Okay, so this is the first task for the EGR 101 thing. So first you go to this page, right? I'm going to put this link in the description. You scroll all the way down and go to the EGR 101, and this is like for everything for EGR 101. So first task is to do Khan Academy, second task is to create the program with the equation and everything, and the third task is to do the what do you call it, the little sheet that we had at the end of the year. So we're going to use this link to go to the Khan Academy, join the class, and here you are. So there's going to be 3 assignments. They're all pretty easy. Position, acceleration, and velocity, applications of circular motion and gravitational force, and significant figures. And they're all due at the same time and date. So let's start with position, acceleration, and velocity. Each one of these are going to have videos. They're each around like 2 to 3 minutes long, just explaining a little bit, teaching you and stuff. But you don't need to watch them. I watch them because, I don't know. So this is, you gotta try getting 100 on this, because, try your best. So an object's position in meters and motion in meters per second can be described by this function during the time interval of this. Which of the following statements is the best description of the object's motion, right? So for these next 4 questions, you're going to need the kinematics formula. X is position, V is velocity, T is time, A is acceleration, and F means final, and I means initial. So that's the formula you're going to be using. So this is the formula right here. X is equal to 10 plus 5t, right? So for this problem, you only need to focus on the tasking for the object's motion. So this is the time interval, so we don't need to worry about that at all for this problem. An object's position in meters of motion, so we're going to be worrying about this equation right here. So, which I just put right here. So this whole part of the equation obviously equals 0, so they didn't put that there. The velocity initial must equal 5. The position initial must equal 10. And that means since this whole area is 0, the acceleration of the object is 0. Because if a is equal to 0, right? Let's just say a equals 0, then that means 1/2 at squared, right? So let's just focus on at. So a is equal to 0. What is 0t squared? That's 0. And what is 1/2 times 0? That's 0. So a equals 0, meaning that this whole part equals 0, which means that's why it's not shown. Next question. A marble is rolling up a ramp with an initial velocity of 2 meters per second at 0 seconds and a constant acceleration of -2 meters per second squared. What can be said about the marble's direction of travel and speed at half a second? So this is going to be the ramp. This is going to be the marble. You push it up with an initial velocity of 2, right? And that's at 0 seconds. And every single second that passes would equal to -2 acceleration. So after 1 second, this 2 would turn into 0, right? Because 2 minus 2 is equal to 0. And half a second, what is half of 2? You may ask. Well, that equals 1, right? So the marble is still rolling up 1 meter per second on the ramp, meaning that the marble's direction is positive, but the speed is decreasing. Make sense? This one is more common sense. So a dog walks with an average velocity of 1.5 meters per second for 10 seconds. What is the magnitude of the dog's displacement? So this one is easy. You just multiply these two together. So 1.5 times 10 is equal to 15. 15. Because this seconds and this second will cancel out, and you'll just be left with meters. A boat is stationary at 12 meters away from a dock. The boat then begins to move toward the dock with an acceleration of 5 meters per second squared. How long will it take to reach the dock? So if it's 12 meters away, right, and it's moving 5 meters every single second, right, then we can use the kinematics equation to solve this, right? So we're going to use the kinematics equation to solve this. So the final distance will be 0 meters away from the dock. The initial distance is 12 meters away from the dock. As soon as the boat starts, it's going to be going at 0 meters per second because, it just turned on, right? And 1/2, the acceleration, it says, is 5t squared. And t is, not found because we're trying to look for seconds, and t equals time. So let's clean this up a little bit. We're going to bring 12 to the other side. So having -12 is equal to 1/2 5t squared, because 0t is equal to 0. We're going to fix this part. So -12 is equal to half of 5t squared, which is 2.5 t squared. We're going to divide each side by 2.5. So negative 4.8 is equal to t squared. Right? Now we're going to find the square root of negative 4.8, which can just be positive, since it doesn't really matter. And since we're doing two significant figures, that'll be 2.2. Right? There we go. And that is the first part of the first task of Engineering 101.